What if I told you that someone actually mapped the coast of Antarctica in stunning, mathematically perfect detail? I mean, thousands of years before the continent was even officially discovered.
It honestly sounds like science fiction, right? But the evidence is right there.
It totally does. Welcome to today's deep dive, everyone. We are pulling from this incredible stack of sources today, mostly anchored by Graham Hancock's Fingerprints of the Gods. And our mission for you today is to piece together this massive historical puzzle.
Yeah, we're talking about the mysterious technology behind ancient maps, lost navigation techniques, and, well, a pretty controversial geological theory that was actually backed by Albert Einstein.
Which is wild because, the implications here don't just add some quirky little footnote to our history.
No, not at all. If this evidence holds up, it completely dismantles the orthodox timeline of human civilization. I mean, we really have to look at these scattered traces of ancient knowledge reaching into our present day and ask ourselves what kind of society could have possibly left them behind.
Right. And to really grasp how big of an anomaly this is, we have to travel back to 1929.
Okay, set the scene.
So, picture this. A group of historians are cataloging items in these dusty archives of the old Imperial Palace Library in Constantinople.
Just digging through old documents.
Exactly. And they unroll this gazelle skin, and on it is a map drawn in 1513 by this well-known Turkish admiral named Piri Reis.
Which, at first glance, a 16th century map isn't earth-shattering. I mean, Columbus had already sailed, right?
Right, but the focus of this specific map is the western coast of Africa, the eastern coast of South America, and, most shockingly, the northern coast of Antarctica, specifically this area known as Queen Maud Land.
And that geographic detail is an immediate, glaring chronological problem.
Because we didn't know it was there.
Exactly.
Yeah.
The official recorded discovery of Antarctica didn't happen until 1818. So we're looking at a document drafted over 300 years before human eyes supposedly ever even saw the Antarctic ice shelf.
And it gets crazier because the Piri Reis map doesn't just portray a coastline covered in massive glaciers. It depicts the actual subglacial topography, like the solid bedrock of the continent itself.
Right, the rock under the ice. Which brings us to this incredible 1960 evaluation by the U.S. Air Force.
Oh, this is my favorite part.
Yeah, so a history science professor named Charles Hapgood submitted this Piri Reis map to a military cartography division. And the response from Lieutenant Colonel Harold Z. Omeyer was just absolute dynamite.
So what did the military actually say?
Well, the Air Force took the 1513 map and overlaid it with a 1949 seismic profile.
Okay, wait, what is a seismic profile?
It's a modern survey where a Swedish-British expedition literally bounced sound waves through a mile of solid ice just to map the rock underneath. And Ohlmeyer's letter confirmed that the geographic details in the lower part of the old map matched the 1949 modern profile with just astonishing accuracy.
So the military openly admitted they couldn't explain it.
Yep. They said they could not reconcile how this was possible, given the state of geographical knowledge in 1513.
It's just mind-blowing. It's like finding a perfectly detailed working blueprint for a modern smartphone tucked away inside a medieval castle. It completely breaks the timeline.
That's a great way to put it. And geological coring suggests that the Queen Maud Land coastline experienced this long ice-free period that didn't completely end until roughly 4000 BC.
Wow.
So the inescapable conclusion here is that the original surveying for this map had to happen before the ice swallowed the coast.
Which places the map makers thousands of years before the Sumerians or the Egyptians, like way before what we call the dawn of civilization.
Exactly. And the map maker himself, Piri Reis, he was surprisingly transparent about all this.
Yeah, he wrote margin notes, right?
He did. He explained he didn't survey these lands himself. He was a compiler. He pieced this map together from more than 20 older source maps, some dating back to classical antiquity.
Like stuff potentially salvaged from the Library of Alexandria before it burned down?
Yes, exactly. So we aren't looking at a 16th century survey. We are looking at a fragmented, continuous chain of knowledge passed down from a lost civilization. And the thing is, Piri Reis is just one piece of the evidence.
Right, because there are other impossible maps.
Yeah, when you look at the broader cartographic record, this timeline of glaciation emerges. You have the Orontius Finaeus map from 1531.
And what does that one show?
It shows rivers and estuaries flowing into the Ross Sea in Antarctica, complete with these totally natural drainage patterns. Today, those specific valleys are completely choked by the Beardmore and Ghat glaciers.
But the map implies there was a massive ice-free hinterland feeding those rivers.
Exactly. And then you go even further back in the source materials to the Buache map from 1737.
Which relied on even older, now lost Greek maps, right?
Right. And the Buache map shows Antarctica entirely ice-free. It even depicts this clear waterway cutting across the continent, dividing it into two distinct land masses.
And we didn't confirm that subglacial division until, what, 1958?
Yep, during the International Geophysical Year, using modern technology. So we have this progression. Maps showing an entirely green continent, then maps showing ice creeping into the interior, and finally, maps showing just the coasts clear.
So it represents like a multi-generational surveying effort, just tracking the freezing of a landmass over millennia.
Exactly. But if we accept that a civilization existed to map this ice-free continent, we're forced to answer a much more difficult question.
Because mapping on a global scale isn't just getting in a wooden boat and sketching what you see.
Not at all. It requires a highly advanced understanding of the planet's dimensions. It really becomes this detective story of lost navigators, and it all hinges on the mystery of longitude.
Okay, yeah, let's break this down. Because finding your latitude, so that's your distance north or south from the equator, is pretty intuitive.
Right, you just measure the angle of the sun at noon, or you use the North Star at night.
But longitude, which is your position east or west, is a totally different beast.
Because longitude is inextricably linked to time. The Earth rotates 360 degrees every 24 hours, which means it turns 15 degrees every hour.
Okay, so to figure out your longitude in the middle of a featureless ocean, you need to know the exact local time where you currently are and compare it to the exact time at a fixed reference point, like your home port.
Exactly. And that time difference tells you exactly how far east or west you've traveled.
But keeping exact time on a ship in, say, the 1700s was considered an impossible dream. I mean, pendulum clocks don't work on rolling waves.
No, they swing all over the place. And temperature swings would warp the metal gears of standard watches.
Right. It was such a crisis for global trade that the British Board of Longitude offered a literal king's ransom to anyone who could solve it.
And it took John Harrison, this brilliant clockmaker, 40 years to invent the first working marine chronometer. His final design was tested in 1761, and that is what finally allowed Captain James Cook to accurately map the Pacific.
So orthodox history tells us that accurate global mapping was utterly impossible before Harrison's clock.
Yet the sources point to the 1513 Piri Reis map, the 1339 Darsert Portolano, and even a Chinese map carved into a stone pillar in 1137.
And all of them place continents at their correct relative longitudes.
Yes, spanning thousands of miles of ocean.
Okay, I can hear the skeptics listening right now asking, well, could they have just gotten lucky? Like maybe they drew a jagged blob at the bottom of the parchment to balance out the map, and it just happened to look like Antarctica's bedrock.
Charles Hapgood actually anticipated that exact skepticism. So he took these source maps to the Massachusetts Institute of Technology.
Are bringing in the heavy hitters.
Right. And they were analyzed by Dr. Richard Strachan. And Strachan completely dismantled the lucky guess hypothesis.
How so?
He explained the underlying mathematics required to project a spherical Earth onto a flat piece of paper. To maintain accurate scale and coastline shapes over 1,000 miles, you have to utilize trigonometric coordinate transformation.
Which is not something you just accidentally stumble into.
You certainly don't. You don't just guess spherical trigonometry. Many of these ancient source maps utilized what we now call an azimuthal projection.
Okay, what is that?
It's a technique where you flatten the globe from a single central point. To do this accurately, you need an aerial perspective, or at the very least, a really comprehensive understanding of the Earth's curvature.
And the advanced geometry to correct for distortion as you move away from the center? Right?
Exactly. You need precision optical instruments. The math essentially proves that a culture existed in deep antiquity that possessed both the theoretical geometry and the mechanical technology to conduct a global survey.
Okay, so if a global seafaring civilization had the math and the tech to map a temperate, ice-free Antarctica, where did they go?
That is the big question.
And how did a continent with flowing rivers suddenly turn into a frozen wasteland beneath 2 miles of ice? This brings us to Charles Hapgood's actual geological theory, which forces us to look at the mechanics of the Earth itself.
Yeah, Hapgood wasn't just some cartography enthusiast. He was a history of science professor. He knew that modern geology relies on uniformitarianism.
Which is the principle that geological change happens incredibly slowly, right? Like tectonic plates shift at the speed your fingernails grow.
Exactly, moving continents over millions of years.
Okay.
But Hapgood proposed a mechanism that happens alongside continental drift, which he called earth-crust displacement.
Okay, so imagine the Earth is a loose-skinned orange. The fruit inside the mantle and the core stays perfectly stable.
Right.
But the entire outer peel, the rigid lithosphere, which is only about 30 miles thick, can occasionally detach and slide over the softer layers below, moving thousands of miles in one catastrophic shift.
Yes, perfect analogy. So a continent that was positioned in a temperate Mediterranean-style latitude could literally be physically dragged directly over the South Pole.
So the climate change wouldn't take millions of years. It would be abrupt.
It would be devastating. Temperatures would plummet, and a massive ice cap would rapidly form. Hapgood argued that until the end of the last ice age, which was roughly the 11th millennium BC, Antarctica was actually positioned about 2,000 miles further north.
Proposing that the entire crust of the Earth slipped sounds like, I don't know, fringe science, until you look at who wrote the foreword to Hapgood's 1953 book.
Albert Einstein.
Yeah, the smartest guy of the century. And Einstein didn't just write some polite, generic endorsement. He was fascinated by the physics of this theory.
He really was. He actually provided the mathematical mechanism for how it could happen. Einstein analyzed the rotational dynamics of the planet. He pointed out that ice is continually deposited at the polar regions, but because of the Earth's varied topography, it isn't distributed symmetrically.
Right.
So the Earth's rotation acts on these massive off-center weights of ice, generating centrifugal momentum.
It's like putting a heavy, wet blanket on one side of your washing machine. When the spin cycle hits, that unequal weight creates a violent wobble. The centrifugal force builds and builds until the entire machine starts physically shaking and moving across the floor.
That is the exact mechanical principle Einstein was talking about.
Hmm.
He theorized that this constantly increasing centrifugal momentum at the poles eventually reaches a critical threshold, and it overcomes the friction between the rigid crust and the semi-liquid mantle.
And when that threshold is crossed, the entire lithosphere is forced to shift over the rest of the Earth's body to find a new balance.
Right. But even with Einstein backing the physics, Hapgood faced intense hostility from orthodox academia.
Well, sure, because it upends everything.
It does. But elegant math and physical theories only go so far. If a 30-mile thick layer of rock shifted and dragged a green continent into a deep freeze, the dirt and the ice should show the scars. The geological fingerprints have to match the ancient maps.
And the physical evidence is pretty staggering. Let's look at Antarctica scientifically for a second. During the 1949 Byrd Antarctic expedition, researchers pulled sedimentary cores from the bottom of the Ross Sea.
Yeah, specifically a sample designated core N5. It was analyzed by the Carnegie Institute using radioactive dating. And the core revealed these distinct layers of fine-grained, well-assorted sediments.
Okay, for those of us who aren't geologists, why does the grain size of the mud actually matter?
Because glaciers and rivers transport dirt very differently. A glacier basically operates like a massive bulldozer. It grinds up everything in its path and leaves behind this chaotic, unsorted mess of boulders, gravel, and rough dirt known as glacial till.
Makes sense. It just pushes everything.
Exactly. Rivers, on the other hand, sort their sediment. The gentle flow of water carries fine, silt-like particles and deposits them in smooth, uniform layers.
Oh, wow.
And core N5 contained this fine-grained river sediment, proving that temperate flowing rivers existed in Antarctica until about 6,000 years ago. Only after that date do we see the chaotic glacial till taking over.
That is wild. That perfectly aligns with the Orontius Finaeus map showing rivers flowing into the Ross Sea.
It really does. And the paleobotany backs it up too. On Mount Achernar, which is this freezing, lifeless rock just 500 miles from the South Pole, researchers discovered fossilized deciduous trees, specifically a seed fern called Glossopteris.
And the biology of those fossils is the smoking gun here. Because deciduous trees shed their leaves, they cannot survive in a frozen tundra.
No, they need warmth.
More importantly, when botanists analyzed the cross-sections of these fossilized stumps, they found 0 frost rings.
That's just huge.
Right, because when a tree in a temperate climate is subjected to a sudden, unseasonal freeze, the water inside its cells expands and bursts, leaving a distinct, scarred ring in the wood.
So these trees were never subjected to seasonal freezing. They grew in a consistently warm environment, incredibly close to where the South Pole is today, until they were suddenly buried by a mudflow.
And if the entire crust shifted, the evidence wouldn't just be localized to the south. If Antarctica got pushed into the polar zone, another part of the world must have been pushed out.
We see that exact mirror effect in the Arctic. In Spitsbergen, which is this island cluster halfway between Norway and the North Pole, paleobotanists found fossilized palm leaves.
Palm trees near the North Pole.
Palm trees require a consistently tropical or subtropical climate. And on Baffin Island, 900 miles from the North Pole, there's evidence of alder and birch trees thriving less than 30,000 years ago. The Arctic Ocean itself was warm for most of the last ice age.
So the lands we currently picture as perennially frozen were once temperate. And the massive ice sheets that crushed North America during the Ice Age were simply sitting closer to the physical North Pole at the time.
It all connects.
We have ancient maps using advanced coordinate math to depict an ice-free Antarctica, seamlessly aligning with deep-sea sediment cores and fossilized tropical plants, all explained by a geophysical mechanism endorsed by Einstein.
That's a lot to take in.
It is, but this forces a deeply uncomfortable question for you, the listener. If this ancient map-making civilization was obliterated by a crustal displacement, how does that change the way we operate today? I mean, what is the lesson here?
Well, it demands a total reevaluation of human progress. We operate under this comforting illusion of a linear timeline. We assume humanity marched steadily forward, from hunting and gathering to agriculture, straight up to quantum physics and orbital satellites.
Right, we assume knowledge is cumulative and permanent.
But these maps and geological cores tell a cyclical story. A civilization rises, maps the globe, understands spherical trigonometry, and then an act of planetary violence resets the board.
The infrastructure of knowledge is incredibly fragile.
Very. A global catastrophe like crustal displacement wouldn't just destroy buildings, it would sever the entire chain of information. The mapping, the astronomy, the mechanical engineering, it all just vanishes.
Because the survivors are thrown into an immediate, brutal struggle for basic calories.
Exactly. Over millennia, the high technology of their ancestors devolves into myths of a quote-unquote golden age. All that survives are a few fragmented maps, dutifully copied by generations of scribes who no longer even understand the complex math used to draft the originals.
It fundamentally shatters our modern arrogance. We navigate our days with GPS in our pockets, assuming we are the absolute apex of the human story.
We think we're at the finish line.
Exactly. But the actionable takeaway from this deep dive isn't just about ancient history, it's about how we process information right now. I mean, why did academia largely ignore Charles Hapgood, despite the physical evidence and Einstein's backing?
Because shifting a paradigm is dangerous.
Yes. Acknowledging anomalies threatens academic funding, tenure, and these deeply entrenched worldviews. Cognitive dissonance makes it way easier to just mock a new theory than to rewrite all the textbooks.
So whether you are analyzing scientific data, navigating your career, or just trying to understand global trends, the lesson is to actively seek out the anomalies.
The outliers.
Right, the data points that don't fit the established narrative, like a 1513 map showing a subglacial mountain range, are almost always where the most profound truths are hiding.
Do not let the consensus blind you to the evidence sitting right in front of your face. And as you go about your day, I want to leave you with a lingering thought based on everything we've explored here today.
Okay, let's hear it.
We've examined what happens when the Earth's crust slips, dragging vibrant, advanced civilizations into a deep freeze and erasing thousands of years of human achievement. And those map makers, they use the universal languages of mathematics and cartography to leave a fingerprint behind.
Right, something that could survive the reset.
So imagine if the lithosphere slips again tomorrow, the crust detaches, and our modern cities are abruptly dragged under 2 miles of crushing ice. What single piece of our current world would survive for 10,000 years? What fragment of our technology would become the impossible, unexplained blueprint for whoever builds the next civilization?
Wow. That is a haunting perspective on permanence.
It really makes you think. Thank you for joining us on this deep dive into the unknown. Keep questioning the map, and we'll catch you next time.